Hello, party people. Sorry. All right, this is 2.5, linear functions of random variables. All right, so we're really starting to transition into statistics now. All right, so what we're talking about here is linear functions of random variables. If you had a bunch of, like in the last section, we talked about like if you had two random variables that were related to each other, right? Like instead of just looking at one random variable at a time, you're looking at two at a time. Well, sometimes you have lots of them. For example, maybe like x1 through xn were like the weights of each of the people in this class. So we had x1 through x36, and we wanted to know things about all 36 of those things together, right, somehow. All right, so in this section, what we're going to be studying is a linear combination of these things. So like, what if I wanted to look at what happens when I multiply each of these by a constant? So like we have some C1 times the first one plus some other number. So these C's are just numbers like 12 or -7 or whatever, right? So a linear combination, all that means is it's just a linear function of these things. Really simple kind of thing. So you could think of things like, if we had x and y, like it could be a 2x minus 5y is what we're talking about here, right? So there's a number times x and another number times y. In this case, like we're allowing there to be n of those variables, not just two though. Or notice the sample mean is a linear combination. So if you add them all up, and divide by how many, that is also a linear combination, by the way. But that is a very specific linear combination that we're interested in, right? Like you could do it as, notice that is a linear combination still. So, by the way, you can get by with just knowing stuff about linear combinations if you realize the sample mean is a linear combination, okay? But here's the key thing. The notes here are abbreviated. Like, you don't have to do very much. I think it's ridiculous how much redundancy, that means they're very repetitive in the textbook, all right? So I've listed exactly the pieces of information you need. You need the definition of independent random variables. You need the 2.49 expression regarding the mean of a linear combination of random variables from page 120. I'm going to write that real quick. What that says is the mean, and you'll want to write it, like go back and double check it. This is all in a subscript. So they're like, okay, if you had a linear combination like the one we wrote up above, and you want to find the mean of that. So this is, remember, the symbol for mean, and this is all subscript. So it's like the mean of this whole thing, okay? If you want to do that, and you know the mean of each one of these things separately, of each of those x's, then you're going to take C1 times the mean of the first x. They write it as mean of x1 plus C2 times the mean of the second x, x2. I know, like there's so many subscripts, sorry. Plus Cn times the mean. So, by the way, this will seem pretty intuitive when you do it, although I know this symbol's really weird. All right, you'll be able to do that no problem, okay? The tricky one is when you're doing the variance of a linear combination of independent random variables. That variance, so it's going to look similar, the variance of, and this is all subscript. All right, so we have the same linear combination. It's all just the variance of this thing. C1 times x1 plus C2 times x2 all the way to Cn times xn. If you want that, you have to square those C's. And then you take the variance of x1. And then you do C2 squared times the variance of x2, and so on. Square the c's. Those constants get squared. This is the thing you'll have to remember. So, you know, like this is just sort of a weird thing, right? And so if I were you, I would like put stars around this, right? And like, okay, that's the weird thing, right? And then when you do a problem, just go back and go, oh, I know there was something weird about variance, okay? And then if you want to find the standard deviation of a linear combination, you would take the square root of this, which is not as easy as just taking the square root of each of these pieces, by the way. All right, let's see. I think when we get to class, we'll just try that. So hopefully you'll just have the notes when, maybe we'll try it real fast. We'll get it started. So on page 124, number 1b, so make sure you, by the way, make sure you do this too. We're not doing that here. All right, but make sure you get that in your notes. But if x and y are independent random variables with means 9.5 and 6.8, so this is the mean of x and this is the mean of y, respectively, and the standard deviations of 0.4, standard deviation of x, standard deviation of y, 0.1, respectively. Find the mean and standard deviation of y minus x. Okay. By the way, y minus x is a linear combination of x and y. It's -1 times x plus 1 times y, plus y. All right, so if we want to find the mean of this, the mean of -1 times x plus y, right? So if we go back and look up above, you have this in your notes now, right? So go look. The mean of a linear combination, you'd take C1, which is -1 times the mean of x, which is 9.5, plus, the C2 is just 1, so I don't need to do anything, right? 1 times 6.8. So whatever that is, what is that, like -2.7? If I do that? So the mean of y minus x ends up being -2.7. All right, I didn't leave enough room for myself. So hopefully I can figure out how to erase. All right, so if I want to do this variance of this, so if I want to do the variance of y minus x, which is really -1 times x plus y, then I have to square the c's, right? That's the thing that's all starred and in red up above. So I'm going to take -1 squared times the variance of x, I'm going to write it all out, plus 1 squared, which is just 1, times the variance of y. And I'm doing it in baby steps because what I want you to see is that -1 squared is just 1. All right? And the variance of x is not 0.4, it's that squared. These are standard deviations. So 0.4 squared plus 0.1 squared. So when you do that, you'll get, let's see, 0.17. All right, so the variance of y minus x ends up being 0.17. All right, so that's, I'm going to skip this one. Maybe we'll do this in class. That'll probably be enough to get you started on homework, by the way. It's not very much there. All right, 2.6 is on jointly distributed variables, and we're just going to get started on this. Once again, you could pause right now and make sure you get all of this done. All right, and then I'm going to go down and just do this example, because the example is really easy to understand. Although I don't really understand ozone, but on page 154, number 1, x is the number of days an ozone standard is exceeded. Y is the number of days particulate matter standard is exceeded. the joint PMF. So now a joint PMF would be joint probability mass function. Joint meaning there's two things, x and y. I don't know why I'm using the mouse to write. I have a stylus. Okay. X and y is given in the table. Okay, so notice, yeah, like if you were like studying like air quality, you might be interested in both of those things, right? Ozone and particulate matter. Don't worry too much about that stuff in Nebraska. All right, but here's the table, okay? So x can only be 0, 1, and 2, and y can only be 0, 1, and 2. And these things in this table are the probabilities. So like this right here, this is the probability that x equals 0, y equals 2. All right, so what we want to do, and so on, right? So there's 9 things in that table. First problem, the first part 1b says, find the probability that x is greater than or equal to 1 and y is less than 2. So x is greater than or equal to 1 would be all of these cells. You guys agree? Greater than or equal to 1. Y is less than 2 would only be these 2, right? Or these 4, right? Less than 2, not equal to 2. So there's only 4. Just like it's discrete, so you just add those up. I don't know what you get, like 0.17 plus 0.23 plus 0.06 plus 0.14. I don't know, that's 20, 43, 6. 0.6, maybe? Okay, so all right, so the probability of this, you add up the appropriate values in the table, just like you did when it was single variable. All right, so let's keep going. Let's try, you could easily find the probability x is less than 1 there. And you'll probably do that for a little assignment right now. What's the marginal PMF of P of x? Marginal PMF P of x. Well, in your notes, I hope you have something like this. It says something like that. All right, it might have an x on here too. Okay, so I have no idea what that means. That's like a crazy looking thing, but let's go up here and think about it. All right, we want P of x, the probabilities about x. Well, if I wanted to know just how x is acting on its own, x can be 0, 1, or 2. If I come over here, I left something in the margin. Notice this is a margin. All right, a marginal, I always think, goes in the margin. Okay, so P of x is, what I want right here is the probability that x is 0. I'm going to put subscript. Probability that x is 0 would just be the sum of these, right? Notice I'm summing across the y's, right? So this is an x equals 0, this is an x equals 0, this is an x equals 0. If I add all those up, that's the probability that x equals 0, and I'll get 0.17. If I want the probability that x equals 1, I would add the next row up. I believe I'll get 0.48. And if I wanted the probability that x equals 2, I would add across here, and I'll get 0.26. Hopefully, when I add those up, I did something wrong. I have some kind of addition error somewhere. I'm sure you guys have already picked it out. Oh, it's this. This should be 0.26. All right. So you probably had it. So when you're done with that, that's the marginal, right? This is just like a single variable probability mass function. And notice they add up to 1. That's how I checked my work just now. I'm like, those don't add up to 1, but these do add up to 1. And all the things about the single variable probability mass functions will hold now. Okay? All right. Well, that's all I have for this video, and I'll see you in class.